Hello, everyone. How are you doing? You doing okay? What's life like for you on this Thursday afternoon? So feel free to unmic and use the chat as always. All good. Had an exam this morning. Oh, what was the exam on? Oh, okay. Hopefully it went okay. Right. Okay. I think, how's everyone? How many have we got? 18 participants so far. Okay. Well, I am recording this session, so I will upload it at the end, as always. And, you know, if you're joining a bit late, then you can watch it then. Talking to the people who are not here. You know what I mean? Right. Okay. So this session, I want to talk about the practical coming up. Yeah. So it's coming up in a few weeks' time. We got the consolidation week next week. And then I think we start pretty much in that week after then. I'm just going to check my calendar, see when it is coming up. So consolidation week next week. Then for some of you, it's the week after that. So week 35, some of you on the 23rd and some of you on the 25th of March. And then the other third of you are on the 29th of March. So hopefully you got that in your timetable, and that won't present any problems for you. So what are you going to do? What's the purpose of this practical? Well, it's really to assess your practical skill in synthesis. Okay, we've done a lot of theory so far on synthesis, and this is the time when you kind of roll up your sleeves and get making something. And the something is one of the reactions we did quite early on, and that's the 1,3-dipolar cycloaddition reaction. So the one where we make a heterocycle by putting sort of two bits together and making a 5-membered ring. So we're going to be making 3,5-diphenyl isoxazoline. Right, so let me share the screen and let me just show you a few resources available. First of all, this Moodle page. Let me just dig that out. There we go. So on Moodle, I mean, let's put the chat to one side at the moment. If you go right down to the bottom, don't have to do it now, but at some point, there's all the documents associated with this practical. Okay, so there is, it's called Practical Skills Assessment. So if you see this PSA, it just means Practical Skills Assessment, which is kind of good news for you because it means your practical skills are being assessed and there isn't an in-class test or anything like that. Okay, so there's no kind of bolt-on written assessment. It's solely based on what you're going to do on the day, which may or may not be good news for you. But if you're prepared and this session is part of that, then you should be doing fine. Okay, so there's some guidance notes. I'll go through those in a minute. There's some little videos there you can have a look through, and there's the safety information, the COSH form, so all the hazards associated with the chemicals involved. There's the slides. I'm going to go through those in a moment. There's the method section, which is kind of pulled out from the slides in Word format. That will also be all available on the day during the practical. Then there's the mark sheet. We'll go through that in a moment. And the other things are hidden because they're not relevant for you this year. I did do something with them last year. Like I kind of had a spectroscopy element to it last year, but I'm not doing anything on spectra regarding this practical. So that might also be good news for you. Right, so let's now go on to, hopefully you've seen that already. If not, have a good look through it. Let's get the guidance notes up. So if you download those, you'll get to this document here. So basically, it's just saying, preparing you for the lab. So read through all the documentation, what I just showed you. Read around the subject of 1,3-dipolar cycloaddition reactions. So we've done a lot in the lecture. Can't remember what lecture number it is now, but it's one of them. I would just look through those lecture slides. That would be useful for you to do. As always with these practicals on the 4th floor of St. Michael's, bring your safety glasses, but no need to bring a lab coat. That's provided for you. And you need to act professionally during the practical session. When I say act professionally, what does that mean? It just means having the right kind of attitude for doing a practical class. So we don't want any kind of fooling around. I mean, I don't mind people talking about the experiment, keeping it kind of relevant to some extent. Social learning is part of it, but there comes a point when you're kind of fooling around, shouting to the other bench down the a couple of benches away, and it gets quite rowdy and boisterous and all that. So that was not being professional. But I'm not saying come with a suit. So but I think what's what. I mean, we did have. Maybe I shouldn't encourage bad habits, but I remember sometimes you get people chewing gum, people not tying their hair up, and people putting ice down over people's backs. I mean, this sort of childish behavior, you should be well past that now, but that sort of thing has happened in the past. But this time we're kind of penalizing that. Yeah, and you'll see that in a minute when we come up with the assessment. Bring a lab book. Last year, I remember Karen insisting on, writing up the lab report as you go, and there's marks for that, and there will be marks for that this year. I mean, as you're writing in a hardback book, I mean, I'm not expecting it to be meticulous, because it's going to be a bit, it's not going to be your tidiest work, is it? If you're kind of writing in a lab, but something. Well, I'll come on to that in a minute when I show you the form. Yeah, I'll show you what would be a good lab book and what will be not so good. Come 10 minutes early and be familiar with the techniques of pipetting liquids using a magnetic stirrer, solvent extraction. I'll say a bit about solvent extraction, but some of these other ones, like recrystallization and melting points, be a bit familiar with that before you come into the lab. You can just Google that and have a look on YouTube perhaps or whatever, and just familiarize yourself if you're not that familiar with those techniques as is. You will learn them if you don't know them already. But read through the marking sheet. We'll do that in a minute. And this is going to count towards 20% of the module mark. So it's a lot of marks, really, isn't it? Just for 4 hours work. Yeah, so 80% for the end of module exam, and then 20% for this assessment. So you want to do well on it. It will be marked during the session, so you will get your mark. You will see your mark before you leave the practical. Yeah, we'll come on to that form now. So if you can't make a session for whatever reason, email me. There might be something we can do about it, but if everyone's changing, it's going to get chaotic, and you certainly can't attend another session without letting us know. So run it past us if you've got some sort of emergency, and then we might be able to allocate you to a different room. If we can't do it, then it have to go to July. I don't really want to do this, to be honest, because it gets a bit awkward, but for you and us, but it might have to. So we'll see what we can do. Yeah. So, but if you just don't turn up to anything and that you've got no ECF, then you'll be capped when you eventually do the mark. When you do the lab eventually. Right, so that's the guidance. So have a look through that. Any questions, let me know. And then there's the mark sheet. Okay, so let's start where you need to be at the end of your practical. Yeah, so this is the mark sheet. So hopefully what you'll get is 38 out of 38. Yeah, 100%. and that will be the 20% of the module mark. So that's what you're aiming for. How do you get 38 out of 38? Well, it's just got to do what it says here. So are you punctual? Have you arrived on time? I know sometimes there's some emergency situations and you arrive late with a good reason. That's fair enough. I'm not going to mark you wrong for that. But if there's no obvious reason, then 0 marks out of 1 for that. So a bit about punctuality. Professional behavior, I said already about, are you turning up ready to do a practical? Are you being well behaved? Have you got the right attitude? Yeah, so the things I said about ice, chewing gum, hair, etc. If you're doing all 3 badly, you're definitely going to get 0. Yeah, so just have a think about that. Normally, I would say you can't go wrong, but life happens and you might get a lower mark in that area. Hazards. You need to know about the hazards involved in your experiment. We will be asking you questions during the practical. So we will say, what are you using? What are the hazards associated with it? If you get good answers to those questions, you'll get 5 out of 5. If you get somewhere in the middle, you'll get somewhere in the middle with the marks. Yeah. So look at the hazards. They're all on the PowerPoint, which I'll show you shortly. And they're also on the COSH form. Yeah. So know the hazards associated with each chemical you're going to use. Sometimes people just say, oh, it's toxic. But sometimes they're not toxic. They're irritant or they're carcinogenic. So you need to know the level of detail we've told you on the PowerPoint and the COSH form. Yeah. So when I say the level of detail, I'm not talking about, sentence by sentence, it has this particular risk phrase and not that level, but you certainly don't want to be saying something is toxic when you mean corrosive, so make sure you know exactly what. Something might be toxic and corrosive, so you need to know that. Yeah, so a little bit more detail about the chemicals involved. There'll be other things about, slip hazards and gloves and why you're wearing certain things. And so there'll be that level too, but down to the chemical level, you need to know a bit of knowledge there. And understanding the procedures you're using. Yeah, so you might be doing a recrystallization. We might say, well, what is a recrystallization? Why does a solvent need to be hot? Why are you cooling that down? Why are you, whatever. So you need to be performing well on those sorts of questions. So this is really, because what you can do, of course, is you can do a really good practical, get a good product, and you're following the instructions perfectly, but you don't know why you're doing it. Yeah. So quite often I have the analogy of making cakes, a bit like cookery. So have you, do you know why you're doing it? You have to grease the tin, but why do you do that? Yeah, you do it, and that's how you do it. But why? So the cake doesn't stick to the tin, etc. Yeah, so it's we'll be assessing the why. Why are you doing certain things? Lab book. So bring a lab book. Are you making some quite detailed notes there? So what are the kind of things you could do wrong here? Well, you can not bring a lab book at all. There will be bits of paper you can write on in the lab will be provided. If you're solely relying on that, then you'll get 0. So you do bring a lab book. It doesn't have to be hard-backed, but it needs to be a book. Maybe not A4 papers, stapled together, but a kind of book of some description. I don't care what's on the front of it, and I don't care if it's floppy or hardback or whatever, but some kind of book. Are you making just measurements of the quantities involved? You're weighing out something. Are you just putting those numbers down, or are you putting some other notes down? Or are you writing in a little bit more detail here? So that's the difference between the 2 and the 3. Not expecting it to be perfectly neat. There's some sort of neatness there, but, I appreciate everyone's got their own handwriting, and you're doing it in a lab environment, so it's not going to be the neatest. But so that's how you get the 3 there. Percentage yield, I mean, that speaks for itself, really. If you're getting 80% yield, you get 6 out of 6. And if you're getting somewhere between, they're the marks. Yeah, so you don't want to be losing too much product, otherwise you lose some marks here. And these next two sections speak for themselves as well. You know, are you making white crystals? What we judge as white crystals. You might say, yeah, they're white crystals. I mean, like, no, they're not. They're yellow. It's a yellow powder. You know, so that off-white, you make the assessment, but we will override it. Yeah, with our comments on whether it's white crystal. Crystals are better than powder, but so you can see how that goes there. So white crystals are what you're kind of aiming for. That's what the product looks like. Melting points, did you do those last year with paracetamol or maybe something else? I think you might have done those. So melting point, a measure of purity. The higher the melting point, the purer it is. So you're looking for 76 as the midpoint. Remember, you quote a range, you know, 74 to 78 or whatever. So we're looking for the midpoints of these to get those sort of values. So we'll see how you're doing with that. Are you having a clear bench as you're working, or certainly how it ends up at the end of the practical? If the technicians have to tidy up everything for you, you'll get low marks here. So you need to be proactive in keeping your bench sort of tidy during the experiment, particularly afterwards at the end. Yeah, so if you've done all that, you'll get 38. So quite straightforward, really. Any queries on that? Do we get our scores immediately after the lab? Yes, you will. Yeah, so you'll know what you get before you leave the lab, unless you leave in a rush. Do we need to wear specific clothes, casual or formal for them? Yeah. Are we allowed to read from our lab books while being verbally assessed? No, you need to know, say the hazards. If I say, oh, you're using, I can't remember what you are using. I'll know in a minute when we go through the experiment. Say you're using chloroform. I'll say, oh, what are the hazards of chloroform? And then you say, oh, it's corrosive and you shouldn't get it on your hands, you know. But then I'll kind of make an assessment based on that, you know. So I'm not saying that's the right answer or the wrong answer, but you should know what it will be. Yeah. So regarding clothes, you can wear anything you want within reason. When I say professional, people think suit. You know, don't wear a suit. Come ready to do a lab. But you know, if you've got long hair, you know, tied up. If you I don't know, don't wear shorts or sandals. Not really the weather for it. Although you do see. I've seen in the height of winter people wearing shorts, so that sort of thing happens. I don't want to see any shorts. I don't want to see any sandals and flip flops and all this sort of thing. Get some decent shoes. Don't go and buy shoes, but you know what I mean. I would say it's common sense, but sometimes common sense is it's not always that common as you might expect. Simply because you might get chemicals on your feet, you know, it's that sort of thing. Yeah. What have we got here? Are the steps going to be printed and pasted on a wall and bench by? Yes, the instructions will be laminated and you'll have them with you. They'll also be on the OH overhead projector. I was going to say it's a bit old-fashioned, on the PowerPoint display in the lab. So they will all be available. So you don't have to bring any notes with you. You take notes as you're doing the experiment, but you don't need to print anything and bring it with you. Yeah, so be kind to the trees. So where are we? That's the steps. So they're all printed for you. Can you repeat about the yield again, because I couldn't hear you properly? My laptop volume is a bit low sometimes. Okay, sorry about that. Yield. So remember, percentage yield is if you made what you expect to make, you know, to the nearest gram or nearest 0.001 of a gram or whatever, you've made 100% yield. If you make half of what you expect, then you're going to make 50% yield. So I'd like you to know the yield calculation, and ideally, why not have the theoretical amount of product already worked out before you even step foot in the lab. Yeah, no, if I start with this amount of starting material, which will be the benzoyl-doxime, we'll go for that in a minute. Is it benzoyl? Yeah. Then I will end up with so many grams of the product, 3,5-diphenyl isoxazoline. So you can walk into the lab thinking, okay, I need to make 4.67 grams of the product. And then you'd have done the calculation before you even start the lab. And so that they might be valuable minutes for you rather than, during the experiment, work out your theoretical yield. You've already done it. You turn up and you've got the number already worked out. That would be good. And that would also be a way of maybe starting off your lab report. You've already kind of made a start. The calculation's there in front of you. But when we start asking questions, I don't really want you reading it from the book. So if I ask about the hazards of something, don't read it from the book. Just look at me and tell me what it is. Yeah. I know that's going to make it like a memory thing a bit, but you need to be a bit aware of what the hazards are with things anyway. Again, remember what I said, it's not that level of detail. It's risk phrase R36, and it's not that level of detail. It's just to know, something is corrosive and it's irritant, or it's toxic only, it's irritant to eyes. It's that sort of level of detail which I've told you in the PowerPoint, but you need to kind of know that knowledge. Let's go back to the chat if there's any other questions. There's quite a few questions. Normally nothing comes up. That's on the wall. That's the yield. Are the steps for the procedures going to be on the wall or bench? Yeah, so we've done that one. Are we working in pairs? You're working in pairs. Yep, working in pairs. How many questions per person will be assessed verbally to get the 5 marks allocated? Don't know. It's going to be fairly random. It's not a big interrogation. It's just to kind of enough for us to be able to say, yeah, you've got a good understanding of experimental procedures. Yeah. So I mean, if I ask a question and you get the answer wrong straight away, I might ask another question, and if that's not quite as good, then so what I don't want to do, I want to give you the maximum chance to do good. But if you kind of stumble on the first question, I'll come up with another one. I want you to do well, so it's not with an intent of giving you a low mark. So if you've answered, I don't know, sort of 3 questions really well, then it's kind of job done. You're going to get a good mark. But if you get a bit rusty, finding it a bit difficult, then you might find, ironically, you get a few more questions to help you, because it might be we've kind of hit a kind of sore point, and let's try and salvage it. So that there isn't a set number of questions per person. For the reasons I've just said that. Can you tidy up at the end rather than as you go? The technicians will direct that a little bit. They might say, okay, you finished that part of the experiment now, you need to put that over there. And if you put that over there, then that's good. If you kind of ignore what they're saying because you're doing something else and you keep on ignoring it, then we're kind of register that as not tidying up as you go. Even if it's perfect at the end, you had to be kind of told a little bit too much about tidying up. So just be aware of that a little bit. Can we choose our partners? Yes. Bear in mind, we're in these sort of COVID days, aren't we? So, I mean, I've got COVID at home at the moment. As you can tell, I'm doing pretty good. But I'm still positive. So it seems to, anyone had COVID? Maybe you had the old COVID, the Delta or whatever, but But those, you seem to be negative for, positive for a short while, then you're negative again. I've been negative every day since last Thursday. No, positive every day since Thursday. I'm a positive person, but I'm also positive on the test. So that's why I'm at home. But remember, you might decide, who your partner is, get it all sorted out, and then they go down with COVID. Heaven forbid. Or, well, even if you get it, it's not the end of the world. As you can tell, I'm doing okay. That's me personally, but it just means you can't come in, so that partner you set up isn't going to happen. So then you have to find another one. Everything will be sorted out on the day. But if you want to come along with someone, totally fine with me. Yeah, okay. Bearing in mind, you've got the groups all sorted. So your best mate might be in Thursday's group and you're in Tuesday. So that won't work. So it has to be within the group. Are we working individually throughout the whole session? No, you work in pairs throughout the whole session. I'll ask you questions individually. So I might have to kind of steer you away from your other partner while I'm asking questions. So you'll be assessed individually in terms of those of certain questions here, but at the end of the day, you're making the same product with your partner. So that will be assessed the same. Are we? Yes, it takes a while to test negative. Yeah. So Chloe, yeah, is it? Did you if you don't mind me asking, just between us, how long did it take to go negative again? I'm isolating more, and the government would say, but I'm in line with the university's thing, 5 days, but then they say, until you test negative twice, but that's not quite happening for me. So 10 days. Okay. So is that the new strain of the COVID, as far as you're aware? I mean, it's not the COVID we had several years back, which, Omicron. I'm sure I've got Omicron because that's the main one, isn't it? So yeah, I've had it 7 days now, although I think I'm doing fine. I don't think my brain's 2% smaller than it was 2 weeks ago, but I don't know. It might be. Right. Okay. Any other questions on this score sheet? I think it's always good to work backwards, isn't it? Work out where you need to be. And then you can fill in the details about what you're adding to what and all that sort of stuff. So we can sort that out in the next sort of half hour. But that's the sheet here. So you should do pretty good on that. I mean, there is an element of chance, perhaps, if your product's not quite. There's things you can do if you're getting a sort of off-white solid. You can clear it up a bit by washing it with solvent at the end. So there's little tricks you can do to bring it back a little bit if it's going off the rails here a little bit. I suppose if the yield's too low, there's not much you can do about it. But with the yield, look. 80% gets 4 marks. Yeah, it's not 100% 4 marks, so it does come away quite nicely in your favor. I mean, even if you're getting sort of 40%, you're still getting some marks here. Yeah, so it's not too bad a scheme to. But I would imagine, there's a lot of things you can control here with the lab book. If you're writing on the back of an envelope, then you're never going to get 0. If you bring a lab book and you put some good level of detail in, you're going to get quite high marks here. So if you're prepared, you know about the hazards, you're going to get high marks here. Then the chance element, that if your melting point's a little bit low, and you can. If you're following the procedure perfectly, you should get high marks. But sometimes it's not always that clear. But so you could lose a few marks here. But then that's still going to give you a high mark overall, even if you lose some marks here. And this will be where you will lose some marks. But other areas, you should be scoring quite highly. Will we be presenting one product at the end as a pair, or do we make our own? Yeah, so one pair per product. Yeah, so working in pairs, there'll be one product between you. But each person will have one of these sheets each. So there will be duplication, of course, with this part, the yield, color, appearance, melting point. There will be duplication. Might be one person's tidier than the other. There might be a little bit of difference there, maybe. Don't know. Right, are we all done on that one? So it should be a fun practical, but just be aware of what's being assessed. And there's always something you should be doing. Yeah, so that I don't think there'll be a time when you're not doing anything during the experiment. Even if you've got waiting for something to heat up, waiting for something to cool down, there's still something you can be recording or preparing for the next stage, etc. Righty-ho. Right. Next one. Let's go through what you can actually do now. This will be probably the last set of slides. Just organizing my page here. Right, so this is what we're making, 3,5-diphenyl isoxazoline. Yeah, so we talked about this in the lectures so far as it's a 5-member ring made by this 1,3-dipolar cycloaddition reaction. So let's. So here it is. That's what we're making. These are benzene rings, as you know. So it's an example of a 1,3-dipolar cycloaddition reaction. And the whole aim of this is to assess your professional and laboratory skills via this PSA. So this will be assessed summatively today on the competency sheet, what we just seen a few minutes ago. And this will make up 20% of your module mark. Here's the reaction. So we might ask you a little bit about this as we go around, 1,3-dipole reacting with an alkene. And we've done about all the curly arrows and all that in the lectures. So I'll ask you a little bit about that, but well, I might do. I can ask you anything, I suppose, but that's something you need to be aware of, the reaction going on. X, Y, and Z. And what they are. This is the specific example for this experiment. Okay, so here we're making, it says that someone's making me a cup of tea. No sugars. Why would I just check your mics if you're making a cup of tea? Feel free to shout out as always. Right, so that's what we're making. Here it is. This 1,3-dipole is here. Look, nitrile oxide it's called. So it's a different functional group than what we've spoke about. We've done a lot about functional groups, and yet here's another one, a nitrile oxide. C triple bond N plus O minus. Yeah, so that's this 1,3 dipole here. Z happens to be a carbon with a benzene ring attached. And the square brackets means it's made in situ. So you don't weigh this out. You start with this thing here, yet another functional group called an oxime, O-X-I-M-E, oxime. An oxime is this nitrogen next to an OH. So we start with benzyl doxime, and then we react these 3 liquids with it. Talk about those in a moment. And this makes the starting material. Yeah, it makes these. So this is where you really start from. But the square brackets means it's unstable. So you don't buy this in and weigh it out. It's made in the reaction vessel. Yeah, so you start actually with benzoyl-doxime, react it with these three chemicals here to make the nitrile oxide, and that reacts with the styrene here. Yeah, this lecture's being recorded. Yeah, so I'll upload that at the end. Yeah, some of you joined a bit late, so you'll get the added advantage of paying it back. Some of you still want to hear it anyway, so you can play this back. So it is being recorded. There's the cough. Right. Styrene. Styrene is an alkene. Yeah, so it's an alkene which is needed. And it happens to have a benzene ring substituent, but that's styrene. So that's the way of getting the other reactant in. So that one's made in situ from the benzoyl-doxime. And then this alkene here comes from styrene. Yeah, so you could draw arrows going from the minus onto the benzene, onto the carbon where the mouse is at the moment. Then the alkene, just like this, going from the alkene to this carbon where the mouse is on that carbon next to the nitrogen, and then going from a triple bond onto a double bond. So in the textbook version here, we have a double bond here and a double bond here. But the reaction also allows a triple bond here. Yeah, so that can be a triple bond. So doubles go to singles. Yeah, doubles here go to singles, but a triple here goes to a double bond here. And it just so happens that that's also a double bond, but it could also react with a triple bond on this one. But then the triple bond would go to a double bond. So again, where the arrow is now, that would be a double bond if that was a triple, but it's not. Yeah, so just be aware of that. That sort of thing might come up in the exam question, yeah, rather than to do with this practical. But just a little bit of theory there, but not too much, because that's mostly being assessed in the end of module exam. Yeah, because we did that in the lectures. Yeah, what's happening in the practical is not assessed in the end of module exam. But because we did the theory here in a lecture, that is being assessed in the end of year module. Yeah, do you see the difference there? But once I start getting into the practical side of it, in the next few slides, that will only happen within the this lab assessment. I won't be asking that in the exam. So that's the theory. What does in situ mean? It just means it happens in the reaction vessel. Yeah, so you make the starting material. You make this one in the conical flask. You don't add it to the conical flask. You don't weigh it out and get it out of a bottle. You make it. That reacts with these to make this. So that's in situ, means it's made in the conical flask, and then that going to react with the styrene. So that's what in situ means there. Right, okay, next slide. Next slide, please. Hazards. So you need to know these hazards. Styrene, triethylamine. Can you say these things? Triethylamine. It's like triethylamine, but if you it's turning into a language lesson now, but can you see the ethyl kind of goes into the amine? Triethylamine, yeah. So people still say triethylamine, but it should be triethylamine. Yeah. So what are these things? Triethylamine is one of these liquids here. Can you see that where the mouse is now? That's triethylamine. So a nitrogen with 3 ethyl groups, CH3, CH2, 3 of those. Yeah, so that's triethylamine, and it's highly flammable. And I won't read it all out, but you need to know that, okay? Certainly need to know it's highly flammable, harmful by inhalation and skin contact, harmful if swallowed, yeah? So you need to know that for that one. And the styrene, you need to know it's flammable, harmful by inhalation, irritating to eyes, yeah? So be aware of these hazards. There's not too many of them. I think there's 2 slides worth. Dichloromethane, DCM. What's dichloromethane? This one here, CH2Cl2. Yeah, so think about methane, CH4, yeah, tetrahedral structure. Swap out 2 of those hydrogens for 2 chlorines. Then you get CH2Cl2. And it's a solvent. Yeah, it's a solvent. Dichloromethane solvent. So it's a suspected carcinogen, category 3. I won't go into what a category 3 is. You can have a look up that if you want, but suspected carcinogen is one to know for that one. Avoid contact with skin and eyes. You'll be wearing gloves and all that anyway, so that would be good. So that's the first list of hazards. There's another list here, the benzaldoxime, irritating to eyes, respiratory system, blah, blah, blah. Ethanol, sodium hypochlorite. It's basically bleach, isn't it? Several years back, we did the experiment and we ran out of sodium hypochlorite. So I nipped down to Sainsbury's local. It just opened at the time, and I got some bleach. We carried on the experiment using this, and it kind of worked, but the product smelled a bit funny because the sodium hypochlorite I bought had some sort of fragrances in it as well to take away that. So it had the bleach smell definitely, but it had some other kind of fragrances there, so that was a little bit funny. Yeah, so in contact with acids, it liberates a toxic gas. Can you guess what that gas might be? Not far from where I lived, they had a swimming pool incident that all the fire brigade were called out because they had this very reaction going on. The swimming pool, I suppose, when they were storing the gas, well, it made a gas. The sodium hypochlorite contacted some acid. Not quite sure why acid was on site, but never mind. It made chlorine gas. Yeah, so the swimming pool had to be vacated. Right. This is the product you're making. No hazards identified, so assume harmful, toxic, and treat as such. Yeah, so we don't know what the hazards are, so we assume it to be toxic, the most harmful. Yeah, so just treat it with care. And then I think we're at the hazards then. So you need to be aware of those hazards. So before you come into the practical, you might want to just look at these, maybe Google these, if you don't know them already, these techniques, be a bit familiar with what you need to, the sort of techniques involved. So I'll be explaining some of these in the next few minutes. So these procedure things will be on the laminated sheet, but again, be familiar with it before you even come into the lab. So you'll be dissolving styrene, that's a liquid, 2.9 mils, and triethylamine, 0.3 mils, and dichloromethane, 15 mils, in a 100 ml conical flask containing a magnetic stirrer bar. Have you seen those magnetic stirrer bars before? Sometimes called magnetic fleas. It's just like a little white, well, it's a bar magnet, but it's coated with some plastic, PTFE, I think. Might be polypropylene. So the idea is it kind of spins around, dissolving up solids, if you've got solids there, or certainly mixing up these liquids. Yeah, so it kind of whizzes around, stirring it up. Maybe go into YouTube or something and then have a look at magnetic stirrer, and you'll see what's going on there. I'm sure most of you used it before, but maybe not everyone. So will these slides be available before next week? Yeah, these slides are all, go to the bottom of the Moodle page, and this very PowerPoint I'm going through will be listed there. So if you go through, right at the bottom of the page, yeah, I mean, a lot of these Moodle pages are in date order, aren't they? Date tabs. But if you scroll right down to the bottom, you'll see this PSA, Practical Skills Assessment, and where it says PSA Lab Slides, that's where I'm on at the minute. So there was a guidance notes, what I did first. Then there's a COSH form there, which is kind of doing what we just said on the PowerPoint, but you can have a look at that too. The lab methods have been kind of extracted from this very slide I'm doing at the moment. So that Word file was constructed from this one. And that's the one which has been printed, and it's also been laminated, and that'll be available on the day. But you can have a look. I don't think you'll find anything there which is not in the slides, but have a look anyway. The mark sheet is what we've looked at previously in the video. Yeah, everything else is hidden. So detailed stuff about the mechanism and spectra you don't need to know. Yeah, okay. So yeah, it's not in the, if you look at the date tab, this PowerPoint won't be there, but what I'll probably do is put some sort of link in where we are at the minute. At the moment, it's just a Zoom link, isn't it? I will kind of say, look down below, and then you'll know where to scroll to. Rightio. So what are we going to do? We add the 3 liquids together. We stir them up. We add sodium hypochlorite. That's our bleach solution. How much of it? Well, it's in the method somewhere. Didn't put in brackets there, did I? Did I say 50 mils? It is in that other. Maybe for simplicity, I took it out of the PowerPoint, but I think I'll put it back in, what the quantity is. From memory, I think it's 50 mils, but we'll get that sorted. I'll put that in brackets here. Yeah. So add the sodium hypochlorite. And add the sodium hypochlorite solution to the flask and cool the mixture in an ice bath with stirring. So what you're going to have is a conical flask containing this one, the magnetic stirrer bar, and also the bleach. So you've got 3 liquids in the conical flask, and then the conical flask is going to be inserted into a ice bowl, which you might remember from the paracetamol experiment last year. And you've got some ice in there. And then underneath that, you've got the actual magnetic stirrer equipment itself, the thing what kind of spins around the magnetic stirrer. So it will be stirring these liquids in ice. Yeah. So, but the ice isn't touching the liquids. You see what I mean? That conical flask of the liquids is being cooled in the ice. And then maintain stirring in the ice bath and add benzaldoxime. This SYN thing, you don't need to know it, but if you want to know it, there's another kind of stereochemistry set of rules, and you'll see one is SYN, SYN, and temporarily I've forgotten what the other one is. One, it's like cis and trans, SYN and something else. If I don't know it, you don't need to know it. But you might want to think, oh, what does that mean? Is it a typo or something? But have a look at, and that should be in italics as well, I suppose. But have a look at SYN in terms, maybe Google SYN and stereochemistry, not SYN as in SIN, but SYN, and then you'll see what that means. I'll do the same as well, just to refresh my memory. It's a bit of an old term, to be honest. So benzaldoxime is the one. This is the one what's going to make us the 1,3 dipole. So you're going to, while it's all stirring, add it dropwise from a pasta pipette. Yeah, so add it dropwise. If you put it all in instantly, or if this isn't cold, then you're going to get problems. And I believe I talk about the problems, maybe not on this slide. I think it's on Moodle elsewhere. I'll tell you where it is. So you might well want to have a look at this one, this preparation for the PSA. If you click on that one on the Moodle site, I put in these little videos. Last year, we had all the COVID thing going on, and all this was online, but we had this practical. It's like an online practical. It's a little bit strange, but it was all based on these videos. So I would have a look at these. Hopefully, will it work? Well, if it goes into Panopto, then let me know if it's not working for you. Okay, so have a look through those videos, and then it tells you about why you're doing certain things. And I call it the what do they call it? Adding this important considerations. Have a look at that one. It tells you about why you need to cool down the reaction mixture and why you need to add the benzyl-doxime dropwise. So do have a look at that one, okay? Right. Again, it's that why question. Why are you doing this? So, in a nutshell, what it is you cool it because you want to form the 1,3 dipole. So if it's not done in ice, that 1,3 dipole doesn't form. Yeah, the nitrile oxide doesn't form. And if you add it quicker than dropwise, the benzyl-doxime, then you get the side products being formed. It doesn't form the product you expect it to make. So that can become an issue. So it has to be done ice cold and then dropwise. Then after that, when the addition is complete, allow the reaction to stir in an ice bath for a further 30 minutes. So again, in this waiting time, you could be setting up like the Buckner flask and funnel. You can be working out your theoretical yield if you haven't done it already. So there's little things you can be doing. And then we're going to do a separation step. So because our reaction mixture is, you've got organic layers and aqueous layers. So if I go back to the starter materials here, you've got styrene, that's organic, that would be non-polar. You've got the amine, so that would be polar. Dichloromethane, that's a non-polar solvent. And you've got bleach, that would be polar. So you've got polar and non-polar together. That's also why we're stirring it. So it's cold to form this 1,3 dipole, but it's being stirred because you want to be bringing these non-polar and polar liquids together. Imagine it's like oil and water, it doesn't mix. So if you kind of stir it really fast, then you're going to be getting that mixing going on. Well, a bit better anyway. Yeah, so that's why it's stirred. But then when the reaction's finished, the product is going to be dissolving in the non-polar solvent. Remember the non-polar solvent? You've got dichloromethane there. Dichloromethane. That's the organic solvent to which the product is dissolved in. But the reaction mixture is going to have a mixture of where you've got a lower organic phase, that's the dichloromethane. So imagine you've got this conical flask of liquids, they're all stirred round, so it's all kind of all mixing up nicely, the minute the magnetic stirrer stops, it's going to separate like oil and water. Now, where oil sits on top of water, and why does oil sit on top of water? Because the oil is less dense than water. But this time we got dichloromethane, which is more dense than water. So the dichloromethane will form to the bottom, and the inorganic layer, the aqueous layer, will be at the top. All the bleach and all that will be at the top, and the organic layer will be at the bottom. So we're going to separate these two using a separating funnel. Yeah, so that's a separating funnel there. So there's the example with oil and water. We won't have oil and water. We'll have dichloromethane and water. So the bottom layer. So we use this separating funnel. If you haven't used one of those already, it's basically just looks like a very wide burette. Yeah, like a conical flask upside down. Upside down, yeah, with a tap at the bottom. So leave it to settle. The dichloromethane layer will go at the bottom. The aqueous layer goes at the top. Yeah, so if you run it out and then close the tap at the interface, that's a good way of separating two liquids which don't mix. Yeah, so two immiscible liquids, miscible and immiscible. Remember that one? Very miscible. There's the translation working. Miscible probably doesn't. Mistable. Miserable, no. Miscible and immiscible. So immiscible liquids are liquids which mix into each other, like ethanol and water. Immiscible are two liquids which don't mix, oil and water. Yeah, so here you've got two immiscible liquids, dichloromethane and water. So you're basically going to separate them off. So we will go through it in the class about how to do it, because it looks, this separation step, it looks quite involved. And we will go through that during at the beginning of the session, and also during the session at the point when you do it. Yeah, because I won't go through all this now because I've got -7 minutes to go. So have a look through that, have a read through. There are some videos and things as well on that Moodle page. So you might want to have a look at these videos. There is one there showing you what to do. And eventually you'll end up with a few extra steps and things. You filter off the solid, eventually you do a recrystallization from ethanol. So paracetamol was recrystallized from water last year. This one, you recrystallize it from hot ethanol. Exactly the same procedure as last year, though. You've done a recrystallization. It's just a different solvent. And then filter off the solid. And here comes your nice white crystals, hopefully. And then exactly the same as paracetamol. Filter it off, get them dry. It's easier to dry them when they're in ethanol, because ethanol is easier to get rid of. And then you're going to do the melting point to assess the purity. So work out percentage yield, work out the melting point, and that's you done. Tidy everything up. And that will be the end of the 4-hour practical. So again, during that waiting around time, that's when we'll be asking some questions probably. Or if if we're getting a bit behind, all the questions will be at the end for some of you. So we'll ask you the questions. You don't need to kind of come and see us unless it's getting very near the end of the session. And for some reason, we haven't asked you anything, but we'll be looking out for those completed forms just as much as you will be. So you'll end up leaving the session with your feedback and marks there and then. Any questions? We're allowed to swap rooms if they are on the same day. You need to email me, and I'll see what I can do. I try to accommodate it best I can. If everyone wants to move to the Tuesday, then there's going to be a problem. Yeah, so if there are a few swaps and it's all kind of organized and it all goes through me And then I check with Anna and it's all accommodatable. And we'll certainly see what we can do. There might come a point when everyone's wants to do a particular session. I imagine a situation when yours is the last practical, and then everyone wants to move to that because they don't want to do one earlier on for whatever reason. Then it might become a bit tricky. So I'll say yes, it's possible, but not in every case. That there become a point when it become a bit chaotic or we can't accommodate it. So where we can accommodate it, well, certainly let us know. If you just turn up to something which isn't your practical, then it's going to be a bit tricky. So certainly don't just turn up to, think, oh, I'll do the Tuesday one instead, because that's going to create a problem. If you run it past us, we'll see what we can do. Is the short answer for that one. So not swapping days, but swapping. Oh yeah, the swapping 432, 426. That could be doable. Yeah, that's more doable. But at the end of the day, we're going to split. Whatever happens, we're going to split it. Half will be in one lab, half will be in the other lab. And that it might end up, if you're like say it's A and B. A in one lab, B in the other, it might end up, not quite working out that way. So within A and B, it might be a bit more random, depending on who turns up on the day. Yeah. But okay, you get the idea. Yeah, drop me an email if I didn't really sort that out well enough. Any other queries? Does everything seem a little bit clearer? It certainly will do if you ever look through Moodle and refamiliarize yourself. I'm realizing I skimped a bit over the method at the end, but I was running out of time. But it's all there for you to read, so have a look. And stuff about drying drying the solvent, with magnesium sulfate, I think it is. So I didn't mention that here, but it's all there for you to read, and we'll talk about it on the day as well. Right, no questions? So I'm way past time, but hopefully you haven't got anything at 4. Right, I'll finish it there. I'll post this up on Moodle as soon as it's processed, and I'll see you when I see you next. Okay, so thank you guys. Have a nice evening, and I'll see you soon.